Excel is a very useful tool in analytical chemistry, which can save a lot of time. Here is examples we can use that to solve the statistic problem. The first example is to calculate average, standard deviation, and relative standard deviation. This is the example. We measured 4 times 821, 783, 834, 855. That's the measured data. So you calculate the average, standard deviation, and the relative standard deviation. The formula is learned in the lecture part. You can see this is the formula for average, this is the formula for standard deviation, this is the formula for relative standard deviation. How can we use Excel? First, you need to arrange this data into one column or one row. Both are okay. So you put all the 4 numbers here. So then you can do the calculation now. For average, you can use the equal average function. Average, you can see it's coming out already. Average, double click, select the data, and parentheses and equal. You got the number. Keep in mind, keep the rising figures. And you can keep 3, or sometimes you can keep one more digit because through multiple times of measurement after the average, you're supposed to reduce the signal figures, reduce the standard deviations. We got the number, we select one more. So you can see you can keep one more. Here, equal. For standard deviation, you use the ST. You can see standard deviation function coming out here. We just select standard deviation for samples. Double click standard deviation for samples because you have limited measurement. Then you select all your data. Then parentheses, enter. And for standard deviation is deviation. We keep to the most 2 single figures. The last one is to calculate the relative standard deviation. That is standard deviation divided by the average and the time 100. So you got the answer again to the most to keep 2 single figures here. And that's the calculation, save a lot of time. The second example is to use that to calculate the confidence intervals. This is the carbohydrate content in glycoprotein, and you have 5 measurement here, and then question is find the 90% confidence intervals for the carbohydrate content. So again, you organize all the 5 data here. That's the data. So then first, you need to know what formula should we use. This is the formula for confidence intervals. You need to calculate the average, find the standard deviation, find the measurement, how many measurements, then you find the student T number here. So how can we find the average? We already learned. You put the average, you type average here, you use equal average, double click, select all the data. Select all the data. You got the answer. Then you find the standard deviation, ST, standard deviation. Don't forget use the standard deviation for sample. Again, you select all the data. 2 signal figures here. And then you find the how many measurements, right? You just use the function called count. Count, select all the data, they will find you how many measurements. It's 5 times. So then when you do the student T, calculation, and that related to freedom and confidence levels. And the freedom will equal the merriment minus 1. That's 4. And the confidence intervals, they already tell us it's 90%, right? 0.90. So then you can do the calculate. You can calculate the student t already. The student t will be t function inverted 2 tails, and then you find the probability that will be 1 minus the confidence level and comma, and degree of freedom is 4. We got this is student t. You can also find this number from our textbook or any book which has statistics there. Student t table is very common table. And then you can do the calculation for confidence interval now. That will equal student t number times standard deviation divided by square root SQRT square root, double click, and a number. That's a number. That's the number you got. So keep in mind, keeps 2 single figures. So then you got this number already. That's average is 12.54 plus minus 0.38. That's your answer. And based on that, we can also do some other statistical calculation to comparison the data. There are 3 cases. Case 1 is compare an average with the accepted value. Case 2 is the compare average with another average. Case 3 is compare 2 methods with different samples. So case 2, case 3, we already discussed in lecture slides. Here, let's talk about, give one example, use Excel to solve case 1 case. Comparing the mirrored result with the non-value. Here's the example question. A core sample which has accepted data is 3.19% sulfur. You know sulfur is toxic. So then you have a new method and got the number, you have 4 numbers which close to that, but you don't know if this new method agree with this. If yes, that means this new method can be used for other co-measurement. If not, that means you use a standard to check this method. If it's not, that means there is systematic errors. We have to find the problem. So we do that in 95% confidence levels. So how can we do that? Again, you find the confidence intervals. If the accepted number is out of this range, that means this method not agreeable with the no answer. If in the range, you can say yes. As we just did in the last example, you just put the merit data in a column. So then you calculate the confidence intervals. First, calculate the average. The average will be average. Select all the data. Enter. You got the number. Make sure keep rising in figures. You can keep 1 more digit because after average, you suppose got more precise data. You can use this. And then you do the standard deviation. ST standard deviation for sample. Again, you select all the data. Make sure keep 2 significant figures. Then you count, right? Count the measurement. Find how many measurements we have. It's supposed to be 5, or it's 4 measurement. So then you find the freedom. That will be measurement. Click this cell minus 1. That's 3. So then you find the confidence level, that's 0.95. And then you can get the student T based on the F and the confidence levels. That's T dot. You can see there are many student T number. You select student T for inverted and the two tail. And firstly, the probability is 1 minus the confidence level and the comma. And then freedom is 3. So parentheses and enter. That's the confidence interval student T numbers. So then you can calculate confidence intervals now. That will be student T number times the standard deviation divided measurement, square root of measurement. So then for more accurate calculation, we need to keep more significant figures. So for math of cell, you keep one more digit. That's your answer. So then you can find the lowest range, the highest range already. So then that for lowest one equal the 3.26, that's the average, minus the intervals, that's 3.20. And then the highest will equal the average plus the confidence interval, that's range. And your mirror data is 3.19, right? So you can see it's not in this range. Theoretically, they are not agreeable with each other. But the 3.20 and 3.19 is very close. So let's keep one more digit, see what that number will be. So we keep one more digit. Oh, that's a 3.195. Still high is not agreeable. So we want to try more to confirm, just like you do the similar test in hospital.